Hi everyone, and thanks for coming to the session. My name is Martin and I just finished the second year of my PhD at Saarland University and DFKI in Germany. Today I want to give you an overview of the work we did on Visuo-haptic illusions, specifically on the design of such illusions. But first, I would like to thank my co-authors Kora, Tony and Antonio. Well, virtual reality is quite powerful, allowing humans to visit a realistically rendered world such as this kitchen space, where you could imagine practicing your cooking skills. However, when touching or interacting with the purely virtual content, the immersive experience breaks. To address this, several haptic approaches have been presented, one being the concept of proxies, physical stand-ins for virtual objects. For example, this proxy pot acts as a stand-in for the virtual pot on the stove. However, it is largely impractical to have a physical proxy for every single virtual object in the environment. This would be essentially recreating the virtual world. To overcome this, researchers proposed the use of Visuo-haptic illusions, allowing a single physical proxy to act as a stand-in for various virtual models. For example, Ban et al. Offset the position of the virtual hand from the position of the real hand, creating the illusion of touching different 3D geometries. So this allows them to reuse the same physical proxy, the cylinder on the left-hand side, for various virtual models. By using illusions in our scenario, we can reduce the number of proxies needed. To do so, we apply an unnoticeable offset to the position of the virtual hand from the position in the real world, enabling a single physical proxy pot to act as a stand-in for various pots of different sizes, as you can see here. However, we do not know which variables affect the possible discrepancy between the real and the virtual world. So imagine a real situation where a human prepares a vegetable lasagna. The person would use different kitchen utensils such as whisks, spoons, and so on. There are various ways how such tools can be grasped or how they can be moved, for example, in a circular or linear motion, or how much the different tools weigh. Investigating and understanding the impact of these variables is crucial because it would allow us to include illusions which remain undetectable for humans into new and existing VR experiences. To untangle such variables, we conducted 2 user studies with 48 participants. In the first study, we explored potential effects of 2 different movement trajectories, linear and circular, targeting the question whether how the proxy is moved affect how much discrepancy may be introduced. And 4 different grasping types, lateral, medium wrap, tripod and riding tripod. To answer the question, does how a user hold an object affect how much discrepancy may be introduced? To isolate these variables, we restricted participants' movement using a camera slider for the linear movement condition and a lazy Susan turntable for the circular movement, not allowing any path derivations. To investigate potential effects, we apply CD ratio manipulations, scaling up participants' virtual movement until they notice the manipulation. By collecting participants' responses through an adaptive interleaved staircase procedure, we determined conservative detection thresholds for the different conditions. Our results suggest that designers can use the same thresholds regardless of the grasping type, which is actually quite good news. Imagine if you would have to consider small changes in hand posture which pretty much occur all the time. For instance, even quite simple interactions such as opening a bottle require seamless transitions between several hand postures. However, for the different movement trajectories, linear and circular, our results were inconclusive. In study 2, we recruited a new set of 24 participants and looked at unrestricted movements, comparing again our 4 grasping types and object masses up to 500 grams. We used the same method as in study 1, however this time participants were completely free in their movement, leading us to the following research objectives. Does the grasping type or the weight of the object affect the possible discrepancy? Our results support the findings from study 1. Different grasping types do not seem to impact the detection thresholds. Additionally, our results suggest that object masses below 500 grams play an insignificant role when designing Visuo-haptic illusions. And at this point, we were interested in whether there exists any differences between restricted and unrestricted movement. For this purpose, we only compared the linear movement trajectories. And we found a significant difference between restricted and unrestricted movements, suggesting that proxies which limit a user's motion, such as steering wheels, levers, or sliders, allow for greater discrepancy. So the more natural, frequently occurring linear movement that you can see on the right-hand side allows for smaller disparity. Finally, we analyzed individuals' proprioceptive accuracy, revealing that the thresholds are widely spread, and participants' performance may be linked to their prior experience in virtual reality. To summarize the highlights of our studies, we could not identify whether movement trajectory requires special attention when designing illusions. In contrast, both studies provided very strong evidence that how a user holds an object does not affect the possible disparity, and therefore can probably be neglected when incorporating illusions. Similarly, study 2 suggests that object masses below 500 grams play an insignificant role, which accounts for most everyday objects. And finally, restricting participants' movement even allows for greater discrepancies, which could, for example, help to improve the perceived resolution of haptic devices. So hopefully this gives you some insights into what to consider when designing illusions for virtual reality experiences that should remain undetectable for humans. So kind of like a recipe. And just to add to that, last year we already identified variables that need to be considered. Just to give one example here, the extent to which a proxy is manipulated, such as the slider here. So we found that smaller manipulations allow for significantly greater offsets. And with this, I want to conclude my talk. Thanks so much for listening.